So YSPA starts with 2 weeks of P sets to understand key concepts. I really like this format because right after we can get into really complex information because we've already understood the base knowledge and we can build off of that in the 4-week residential program. Since YSPA is a 6-to-1 student to teacher ratio, there's tons of time to talk about problems and have in-depth discussions with the faculty. And as a result, I'll be able to push myself while having easily access to mentors that truly care about my education. So I think what's really cool is that every single morning I wake up, I'm going to be able to be at the Leitner Digital Planetarium Theater. So I can learn how to use an observatory and I can see real stars, like literally witness them in real life. And that's really cool for me because I come from a place where there's really severe light pollution and I don't see any stars when I go outside. So really being able to see the present stars in the universe while simultaneously having the recorded version of them in the planetarium is just insanely cool. At YSPA, there's a plethora of topics being taught. For example, observational astronomy is one of them. There, I'll be able to learn how to record data from the observable universe, and rather than just kind of look at it, I'll be able to make meaningful results and see trends in cosmological data. Furthermore, rather than just making electromagnetic spectrum observations, I'm also interested in multi-messenger astronomy, i.e. observations from multiple POVs like gravitational waves, neutrinos, cosmic rays, and I can even go beyond that, beyond radio astronomy, and go into different kinds of astronomies like the infrared to gamma rays, as you can see from the Crab Nebula galaxy. Doesn't even stop there. I can learn about stellar evolution, the process of a star over its entire lifetime, and how it starts from these collapsed clouds of gas and dust, and through gravitational pulls they become protostars, and over time they become main sequence stars, and then through nuclear fusion they become huge red giants, and over time either become black holes or neutron stars. An unexpected topic that I found from the curriculum was genetic algorithms, which use natural selection to create high-quality optimizations such as decision trees to solve even something as trivial as Sudoku puzzles. So I think it'd be really interesting to kind of combine something like astrophysics and CS together and see how these different fields of science really come together. Now, not all the topics are that interesting. I'm looking at U statistics and uncertainty in measurements. And that's exactly why I want to attend YSPA. There I'll be able to get out of my comfort zone and understand topics that are essential to becoming a great astrophysicist, even when I won't like them all the time. I think what makes YSPA so special is the fact that I can meet people that are just as passionate for astrophysics as I am, and because it's only 36 people, I get to know these people extremely well. One mystery that still fascinates me is dark energy. Unlike dark matter, which appears to suck in galaxies by bending light, dark energy accelerates the expansion of the universe. It pushes galaxies away from one another and thus expands the space between them. And when I learned about dark energy, I was just gripped by another mystery. If gravitational forces were at the heart of cosmological interactions, how was it possible for the universe to be accelerating outward? And the answer was black holes. Apparently, some astronomers have found out by studying supermassive black holes that dark energy, an intrinsic property of space-time, is contained within these black holes. And this makes no sense at first glance because black holes, they squeeze matter into an infinitely small point to become as dense as possible. So how could they contain dark energy, which is supposed to accelerate the expansion of space? And these kinds of mysteries are at the heart of why I love astrophysics so much. I want to be able to discuss those mysteries, share those mysteries, talk about them with all of my teammates because that's just what makes astrophysics so interesting, making all these theories, ideas from data that is real. This year at YSPA, I'll be able to make 3 more friends in research. Together, we'll build our own research project and I'll develop my own communication and teamwork skills, which I can carry later on into future academic projects that I take on with my classmates at school or even future professors, hopefully, that I can work with.